All right, hello and welcome back. This is the final video for the second lesson in Module 3, where we're dealing with solving quadratic equations with a single variable in it. Our first question here actually refers back to the exercises we did in the previous video. So it says to analyze the solutions for exercises 2 through 4. Notice how all the questions had x minus 3 squared as a factor, but each solution was different. We had radical solutions, mixed numbers, and whole numbers. Explain how the structure of each expression affected each problem solution pair. So let's take a look here. All right, so let's go just to number 2 first. So number 2, this is what we started with, right? And we ended up with two whole numbers, 4 and 2. So why did that work out? Well, in number 2, okay, we took the square root of a perfect square whole number. So we got perfect square whole numbers, or whole number solutions. Since x minus 3 also has a whole number. Okay, in number 3 though, okay, what did we get for our answer number 3? In number 3 we got fractions. Okay, rational numbers as our answer. Why? Well, if you look right here, right, the square root of 1/4 was also rational. So after taking the square root, our answer was rational. So adding 3 also made our solutions rational. Okay, rational again just means, number that can be written as a fraction. Okay, so in these cases, right, our fractions were 7/2 and 5/2. The last solution here though, right, that 6, when we square rooted it, is 6 a perfect square? The answer is no, and so we end up with what is known as an irrational number. So number 6, after taking the square root, our answer was irrational, and adding 3 still resulted in irrational answers. Okay? Finally here, we have Peter here. Peter is a painter, and he wonders if he would have time to catch a paint bucket dropped from his ladder before it hits the ground. He drops a bucket from the top of his 9-foot ladder. The height h, that's important, so h represents height, of the bucket during its fall can be represented by the equation h equals -16t squared plus 9, where the height is measured in feet from the ground, and the time since the bucket was dropped, t, is measured in seconds. So t, time in seconds, h, height in feet off the ground. After how many seconds does the bucket hit the ground? Do you think he would catch the bucket before it hits the ground? So we want to know, when does it hit the ground? Hitting the ground means what? If we know the bucket's hitting the ground, well, let's think about this here. It's asking how many seconds. That means we're trying to figure out t equals what? Right? Does the bucket hit the ground? So hit the ground, that's a height, right? What's the height when the bucket's hitting the ground? H equals 0. So we're going to put a 0 in for this h right here. And solve. So subtract 9 on both sides. Divide both sides by -16. So t squared equals positive 9 over 16, square root both sides. T equals plus or minus 3/4. But of course, in this situation, right, a negative 3/4 would not make sense. Okay, can't go back in time. And so we just have 3/4 of a second. That's how long it will take for the bucket to hit the ground. Now, do you think he could catch the bucket before it hits the ground? And this is up to you a little bit here to decide about whether you think that's reasonable or not for someone to him to catch the bucket before it hits the ground. Okay, most likely, the answer would be what? Peter will not have enough time. To reach the ground to catch the bucket if he is also dropping it, which it sounds like he is, right? If he had a friend that was at the top of the ladder and dropped the bucket, well, then of course he could position himself so that he catches the bucket, right? But remember also, catching it before it hits the ground, I mean, I guess he could always put his hands like right at the ground level or something like that, but he would have to be even faster than 3/4 of a second to catch it so it doesn't hit the ground. At 3/4 of a second, it hits the ground, so he would need to be faster than 3/4 of a second to stop it from hitting the ground. So, probably not. So, by looking at the structure of a quadratic equation, missing a linear term, perfect squares, factored expressions, you can find clues for the best method to solve it, right? So like factoring did not really work on these earlier problems. Some strategies include setting the equation equal to 0, right? That's the zero product property stuff. Factoring out the GCF or common factors and using the zero product property. And that's what we did in previous problems, but in this case, it wasn't super helpful. Be aware of domain and range for a function presented in a context, like word problems, right? And consider whether answers make sense in that context, right? That's just saying, don't put negative times, right? So don't include negative times, and stuff, or negative heights or anything like that. Okay? Thank you very much. We'll see you in the next lesson.